Hello everyone, I'm Varun, Assistant Professor, Department of Mathematics, SJB Institute of
Hello
Technology.
everyone. In this session, we will discuss regarding numerical methods, which is module 5 in your syllabus. Okay. In module 5, we have already Newton-Raphson method and regular falsy method. Both were used to find roots of either transcendental or algebraic equations. Uh, Continuing further, we will look into construction of finite difference table. So, in your syllabus, you are having Newton forward difference, Newton backward difference, and Newton divided difference formula. Okay, and further continuing, you also have a Lagrange's interpolation formula also. So, for solving any problem related to interpolation, we need, in the first stage, interpolation with equal interval, we need finite difference table. So in this session, we will learn what is finite difference table. Then in the upcoming sessions, we can just go through what is forward and backward differences. Okay. So to explain what is finite difference table, I will directly take an example of a problem. Okay, I have been given construct a finite difference table for the following table or data set. Okay, I have x values to be 0, 1, 2, 3, 4, 5, 6, and y values to be 1, 3, 11, 31, 69, 131, and 223. Right. So, first of all, whatever table is given to us, we will write it in vertical order, right? The same thing, whatever we had it row wise is now written in column wise. So x value, as you know, it is 0, 1, 2, 3, 4, 5, 6. We always have practice whenever it is finite difference table. We will take the first value as x naught and the corresponding value of y as y naught. Okay, let me repeat. The first value over here is 0, that is taken as x naught, that is considered as x naught, and the corresponding value of y at x is equal to 0 is taken as y naught. Accordingly, 1 is written as x1, 2 as x2, 3 as x3, 4 as x4, 5 as x5, 6 as x6, and their corresponding values of for x1 it is y1, for x2 it is y2, for x3 it is y3, for x4 it is y4, for x5 it is y5, and finally for x6 it is y6. Okay, there is one more point here. The last values is also treated as, the y6 value, the last value, there is a practice of writing it as yn. Okay, the first value is always x naught, y naught, and the last value, if we have more numbers, we can mention with numbers, as well as we can also write it as xn and corresponding value as yn. Okay, so can we construct finite difference table for any type of table given to us? When such question arises, well, keep this thing in mind, as we already know that here x naught is equal to 0, x1 is equal to 1, x2 is equal to 2, x3 is equal to 3, x4 is equal to 4, x5 is 5, x is 6. Now, one thing is clearly visible that, let me just explain in a good way. If I take the difference between x1 minus x naught or x2 minus x1, right, or x3 minus x2, x4 minus x3, x5 minus x4, and finally xn or x6 minus x5, right? In all these cases, if anybody can make a clear observation that x1 minus x naught is 1, x2 minus x1 is 1, x3 minus x2 is 1. Agree? Do you agree with this? Okay, 3 minus 2, 4 minus 3, 5 minus 4. See, x1 minus x0 it is. You should not take it in the reverse way. Getting it? It's always the preceding value has to be subtracted with the succeeding value. Okay? So 1 minus 0, 2 minus 1, 3 minus 2, 4 minus 3, 5 minus 4 and 6 minus 5. So all these values are 1. So in such case, we can observe that everywhere the interval length is 1. So whenever I have interval length to be equal, okay, yes, here interval length is 1. And of course, interval length is usually denoted by small h. In most of the authors they claim, they mention interval length to be equal to some h, and there are a few authors who also take it as p. That's not a big issue, okay? But we will consider that to be some small h, okay? When you have equal interval, equal distances between any 2 points, okay, we can construct finite difference table. Right? If it is unequal, we can't, even if we construct finite difference table, it won't give us any proper solution. So there is no use in constructing finite difference table. Is it fine? Clear? Okay. So in the next stage, of course, we will, with all this logic, we will start constructing the finite difference table. First of all, we will write x and y as columns. Okay. Then I want you people to observe x0 value is 0. Now how about y0? It is 1. In the next stage, x1 value is 1, y1 value is 3. Now to construct finite difference table, our habit is to subtract 3 minus 1, like y1 minus y0. In the next stage, y2 minus y1. Then y3 minus y2. y4 minus y3. y5 minus y4. So on. Okay. Let us just have a look into that. It's like, yeah, as I told you, 3 minus 1 is 2. In the next stage, 11 minus 3 is 8. 31 minus 11 is 20. Okay. 69 minus 31 is 38. 131 minus 69 is 62. And finally, 223 minus 131 is 92. Okay. Once again, I'm explaining you. It's 3 minus 1, which is equal to 2. 11 minus 3, which is equal to 8. 31 minus 11, which is equal to 20. 69 minus 31, which is equal to 38. 131 minus 69, which is equal to 62. And finally, 223 minus 131 is equal to 92. Getting it? Simple? So this is the first stage of finite difference. Continuing it, yes. In the second stage, it's about the next two values. What I mean is 8 minus 2, which is 6. Right? Continuing it, we will be getting 20 minus 8, which is 12. 38 minus 20, which is 18. 62 minus 38 being 24. And finally, 92 minus 62, which is 30. Let me elaborate. 8 minus 2, 6. 20 minus 8, 12. 38 minus 20, 18. 62 minus 38, 24. 92 minus 62, which is 30. Are you clear with it? Getting it? So it's all about subtraction, right? So in the next stage, continuing this, right, the first difference column we have already got, the second difference column. Now we will continue with this and find the third difference column. Yes, it's the same procedure, 12 minus 6, which is giving me 6. Then 18 minus 12 is again 6. 24 minus 18 is again 6. 30 minus 24, finally it's 6 again. Now let me repeat it. 12 minus 6 is 6. 18 minus 12 is 6. 24 minus 18 is 6. And finally 30 minus 24 is also 6. Getting it? Easy? Now anybody can make one small observation here to go for the next stage. It is like fourth difference column. Okay? We can easily make out that it is 6 minus 6, 6 minus 6 and 6 minus 6. Right? So in all the way it is 0. Right? 6 minus 6, 6 minus 6, 6 minus 6. In all the places it is 0. So, dear students, if I continue from here, quite obviously we can make out that 0 minus 0 is again 0. You will be getting two numbers in the next stage being 0. Next to that 0 minus 0 will be again 0. Okay. So, it's better we stop here. Okay. So, when the entire column, right, when the entire column is 0, it is an indication for us that we can stop at that point of time. Okay, so this is our finite difference table for the given problem. Yes, we will just write it in order. Okay, first difference, second difference, third difference, and finally fourth difference. Right. One more important thing, we have a practice of writing something like converging style. Like you can make observation over here, like it's coming in a V shape. Okay, it's tending towards one point kind of thing. Okay, so in that way we will construct finite difference table, and the place to stop finite difference table is either you have to get the entire column to be 0, that is whatever happened with this problem. There is another stage which will be explained in the next problem. Okay, and for now I don't think I mean, I think we people are comfortable with this, right? It's a very simple problem. Okay, let us just look into one more problem. Right, construct a finite difference table for the following table. Yes, x value is 0, 10, 20, 30, 40. Y is equal to 1, 1.5, 2.2, 3.1 and 4.6. Once again, x0 is 0, x1 is 10, x2 is 20, x3 is 30, x4 is 40. Yes, and the difference between all of them, if we can make an observation, so it is 10 minus 0 is 10, 20 minus 10 is 10, 30 minus 20 is 10, 40 minus 30 is also 10. So one can come into a conclusion that h value over here is 10. Right? So h value is 10. So definitely we can construct finite difference table. Okay? So keeping that in mind, we will proceed in the usual way. Yes. Now we have to write it vertically. After writing it vertically, our target is y1 minus y0, which is 1.5 minus 1, which is 0.5. 2.2 minus 1.5, which is 0.7. 3.1 minus 2.2, which is 0.9. 4.6 minus 3.1, which is 1.5. Comfortable? No, I want you people to look into this. I will not explain this in detail. Yes, it's a very, very simple problem of subtraction. Okay, so you have to look into this. All right. So in the next stage, zero point 0.7 minus 0.5 is 0.2. 0.9 minus 0.7 is 0.2 again, and 1.5 minus 0.9 is 0.6, right? Next to that, yes, 0.2 minus 0.2 is 0, 0.6 minus 0.2 is 0.4, and finally 0.4 minus 0 is 0.4. And as I told you earlier, we are supposed to get it something like a V-shape kind of thing, right? And we can also make an observation here. The last column is having only one number, so we can't proceed further. And here it stops. Either the entire column has to become 0, like your previous problem, or the entire table has to tend towards one value, like in this problem it tended towards 0.4 as just one value. Okay, so yes, this is our conclusion. We can stop like, yes, this is the final stage of finding finite difference. So hope you had a good session now, right? Two problems which we have solved today is just to give a small insight about the finite difference method. Okay, and what I'm looking forward is in the next stage I'll be giving you a few problems as assignment, and everyone must take it seriously. Okay, that's all for today. Thank you.